In this video, I'm going to give you an example of how to find limit for a function. The function is sine of 1 over x. So we want to find the limit of this function as x approaches 0. I'm going to do this problem slightly differently using something called sequence approach. So let's go ahead and find a sequence that approaches 0. So my first sequence is going to be this: 1, 1/2, 1/3, 1/4. As you keep going, this sequence approaches 0, no doubt about it, right? However, what I'm going to do, I'm going to take this sequence and multiply it out by a constant. That constant is going to be 1 over pi. So new sequence is going to be nothing but 1 over pi, comma 1 over 2 pi, comma 1 over 3 pi, comma 1 over 4 pi. And this sequence obviously also converges. It converges to 0. Just because I took the original sequence and I multiplied it by a non-zero constant, that's not going to change the convergence or divergence of the sequence. So I multiplied it by a fixed constant, 1 over pi, and I get this new sequence. It also converges. Now let's go ahead and try to approach 0 using this sequence. And see what we get. So let's just create a table. As you can see in this table, as we go through the sequence, so when x is equal to 1 over pi is going to be sine of 1 divided by 1 over pi. If we simplify it, we get sine of pi, which is 0. Similarly, when x equal to 1 over 2 pi, sine of 1 divided by 1 over 2 pi is sine of 2 pi, that is 0. And in exactly the same way, sine of 3 pi is equal to 0. And you're going to get sine of 4 pi, sine of 5 pi, etc., etc., etc. So all of these things give me an output value for this function to be 0. Doesn't matter what I put as an input to this function, okay? The output is always 0, so long the inputs are coming from this sequence. And this sequence converges to 0. So you can think of it as one path or one way to get to 0, okay? So your x is gonna go towards 0, but by following this sequence, that's perfectly valid. So from this, I conclude the following. So limit x approaches 0, f of x is equal to limit x approaches 0. My f of x is nothing but sine of 1 over x is equal to 0. By using, let's call it sequence 1. So I'm going to call this S1 or sequence 1. So for S1, I get this result. Now I'm going to create a sequence 2. Let's call this S2. This time my sequence is going to be 1, 1/3, 1/5, 1/7, 1/9, and keeps going, this sequence. And as you can see, this sequence values approach 0 as well by taking a different path, okay? By taking a different path, not like this one here. However, this time what I'm going to do, I'm going to take this sequence and multiply it by 2 divided by pi. Again, this is a constant, by non-zero constant. By multiplying it by a non-zero constant, you're not going to change the convergence or divergence of the sequence. So if I simplify it, I get 2 over pi, then 2 over 3 pi, 2 over 5 pi, 2 over 7 pi, 2 over 9 pi, and so on. Technically, this is what I mean to be my sequence 2, okay? So now let's go ahead and take these sequence values and let's approach 0 using this path. So this is a different path I'm taking, and let's see what values we get for the function. And let me create a table here too. As you can see in this table, for x is equal to 2 over pi is going to be sine of 1 divided by 2 over pi, which is sine of pi over 2, and that is going to be equal to 1. Now when x is equal to 2 over 3 pi, then what happens? You get sine of 1 divided by 2 over 3 pi, that is sine of 3 pi over 2. If I simplify 3 pi over 2, I could write it as pi plus pi over 2. So that's going to put you in the third quadrant, right? So sine is negative. There, so it's going to be negative sine of pi over 2, which is negative 1, which is what I have. And one more example. So if you have x equal to 2 over 5 pi, then what happens? Sine of 1 divided by 2 over 5 pi is going to be sine of 5 pi over 2. That is going to be sine of 2 pi plus pi over 2, which is going to put the ultimate angle in the first quadrant. That's going to be sine of pi over 2, that is 1. As you can see, for these values, if I follow this sequence, the sign kind of goes between positive 1 and negative 1. So for S2, limit, again, I'm going towards 0, right? Limit x approaches 0, f of x is equal to limit x approaches 0, sine of 1 over x is actually either 1 or negative 1. So that means it doesn't converge for this sequence. If a function has a limit for a particular value, it must be a unique value. It cannot be two different values. And what makes it even worse, look, I take two different sequences. So sequence 1 gives me, if I go towards 0 by taking a path, what I call, which is sequence 1, I get 0 for the function, okay, the limiting value of this function. On the other hand, if I take sequence 2, right, sequence 2, I get something even more stranger, which is what? Either 1 or negative 1, which is completely different than 0. So I have taken two different paths or two different routes. Both of them lead to the same destination, which is 0. Think of it as a number line, okay? So this is your 0. Your objective is to go towards 0. In one case, I go towards 0 using sequence 1. In another case, I go towards 0 using sequence 2. Doesn't matter which sequence I follow. If the limit of a function exists, it must yield or it must give the same result or same final output. However, in our case, for sequence 1, I got a 0. For sequence 2, I got two different possible values. That means it flip-flops between 1 and negative 1. If this function, if the limit for this function existed for x equal to 0, it didn't matter what sequence we take or what path we take to get to 0, it should always give me the same value. So the conclusion is that limit x approaches 0, f of x, or limit x approaches 0, sine of 1 over x, it does not have limit, okay? Limit doesn't exist for this. If you graph it, you'll probably see something like this. Towards 0, it goes something like this, okay? In the neighborhood of 0, it fluctuates. So that kind of is a visual way of kind of verifying that, oh, the limit for this function does not exist. I hope that this discussion was helpful. Thank you very much.